Welcome back to Reconstructing Relativity, Chapter 10, Thoughts on Truth. If you've gotten to the end of any of my videos, you see that I have a book on the same topic. It's called Reconstructing Relativity, an Inquiry into the Nature of Truth. So that issue of truth is part of the whole story, which I want to start wrapping in a little bit more. So today I'm going to be reading from the book, as I think that's a better presentation of my thoughts than just rambling here on YouTube. So I'm going to be reading from my book, but I'm reminded that there's a video on YouTube called 10 Hours of Nothing, which is pretty awesome. 10 Hours of Blackness with no audio. And a commenter down below wrote the comment, "For full screen, close your eyes." And so consider that option here too. Don't let the visuals distract you from listening to my thoughts on this. And then next video we'll get back into the things we've been doing: reference frames, time skewing, and measurements of relativistic effects. And we'll see how all that plays out. So let's get going. I'll start the reading. There has been a philosophical debate which dates back to the Greeks regarding whether truth is relative or truth is absolute. From the time of Newton to the early 20th century, the dominant Western philosophy was that truth was absolute. Space and time were absolute. Physical phenomena were considered determinate. If there was a lack of certainty, the only deficiency imagined was an inability to gather a sufficient amount of precise data. This view of reality dominated Western thinking until Einstein. Relativity established truth as a relative entity. Space and time are no longer considered universal absolutes. Different observers can perceive events differently, and both observers are considered to be correct. Even the sequence of events can be perceived differently, and both observers are still considered correct. Their perception of the facts is relative. It depends on their state of motion. The very word relativity defines this philosophy. The different observations of reality which multiple observers can all correctly hold is defined by their motion, but not their motion relative to some absolute universal frame. Einstein says that their different perceptions of reality are defined entirely by their motions relative to each other. As Einstein and modern physics sees it, there is no absolute reference frame. There is, therefore, no absolute truth. Different observations of reality are all held to be equally valid. Science is a philosophical pursuit which values measurement in its attempt to understand reality. Measurements involve an experimental subject, the experimenter, observing an experimental object. The subject-object model is not perfect when people, who are composed of molecules and atoms and subparticles, set out to do experiments on atoms and subparticles with measuring equipment that is also composed of atoms and subparticles. In such experiments, some subtle issues may arise which need to be carefully considered before drawing definite conclusions. If, on the most fundamental level, we are made of the same stuff as light, whatever happens to light also happens to us. The subject and the object are, in one important sense, one, not two. This should not prevent us from thinking about the universe we see, but we should be very careful about our premises and our scientific process. We should consider exactly what measurement is and include awareness of this analysis in our philosophical valuation of measurement above all else. What I'm proposing is the philosophical notion that there is one and only one true reality, an absolute truth, which we might call the evolving state of the universe, which cannot be objectively measured because we cannot remove ourselves from the universe to make an objective measurement. The absolute truth, I suggest, is a reality which no intelligent physical observer can claim to definitely, absolutely know. To propose this notion is a philosophical pursuit which scientists are almost certainly bound to reject because it cannot be tested with a scientific subject-object experiment. But this is not a scientific proposal, it is a philosophical one. The test of such a philosophical proposition is not whether it is physically provable by measurement, but whether it is philosophically more harmonious than the current philosophical model represented by relativity as it is currently viewed. Of course, any new alternative philosophical model, to be credible, must remain consistent with experience. The new model must still fit the existing data. That is, in this case, it must be consistent with more than a century's worth of experimental evidence. But if an imaginable constructive model can be demonstrated which is consistent with the facts, refers to a notion of absolute truth, and also presents more philosophical harmony than the current notion of relative truth, I suggest that the debate over the nature of truth should not be considered closed. Einstein said that there is no preferred reference frame, which simply implies that no single observer can claim to know absolute truth. But because science values measurement above all else, science reached a critical juncture with relativity. Because multiple observers traveling at different speeds relative to each other will obtain different measurements of the same objects and events, including measurements of an object's mass and size, science decided that each observer has his or her own personal truth, his or her own personal reality, and that all of these different truths are all equally valid. The reason Einstein rejected the concept of the uncertain absolute is that experimentally, the absolute frame could not be located. But beyond that, Einstein liked the notion that the laws of physics should be identical for all observers, independent of one's choice of reference frame. He saw an elegant symmetry in that notion. Speculation about an absolute spatial reference frame was moot, he said, for all practical purposes. And there's the key: practical purposes. Einstein's practical purposes involved measurements and predictions. I will argue that there is at least one practical purpose for which the concept of the existence of an absolute frame of reference is useful: the practical purpose of understanding what is physically happening, for the practical purpose of making relativity make sense. Although an absolute reference frame has not yet been experimentally located, it can still be conceptually imagined. While agreeing that such a non-moving frame may not be preferred over any other, it should also not be banned from consideration if it provides some value in helping us imagine the physical phenomenon in our mind's eye. I've found that for practical purposes, such as relating measurements in one moving reference frame to measurements in a different moving reference frame, imagining or establish a non-moving frame is purely a pain in the butt. Why in the world would anyone want to refer data in a real moving reference frame A to an only imagined stationary reference frame B, and then from frame B to a different real moving reference frame C, when computations can take you from frame A to frame C directly in one easy step? Indeed, it's impractical, it's a waste of time, and completely unnecessary. But the imagined stationary reference frame B happens to be the one place you can go in your mind's eye if you want to see what is happening physically. And that's what I want to do. I want to slow down, back up, and look at the big picture. I want to burrow down into relativity and see what's really going on to make sense of it. I want to demystify it and make it understandable by every person who cares to think about it, not just by the experts. All right, we'll wrap it up now. I'll come back next time for more actual relativity with time skewing, reference frames, and measuring stuff. And if the copyright gods will allow it, I've got a piece of music. And thanks again for watching. Catch you next time.